Okay, the venerable 530S is back together after taking this, they call it the counter assembly. I assume that's just a frequency counter. But you can see the new high voltage filter capacitors. They're about half the volume of the original. Another 100 volts rated, another 20 microfarad. So instead of 100 at 500, the 120s at 600, and that came in very useful. This board here is an utter peg to work with and difficult to put back in. They've got all these wires running willy-nilly. The previous owner that took this board off to connect this filter pinched a wire that goes to the plate of the driver tube. So not good. Also broke off this socket, probably by picking it up and shoving a thumb against it. That's just the right distance for a thumb. His hands were a little bit larger than mine. But be extremely careful putting this counter assembly back in. Take this capacitor out, or better yet, to get the foot out of the way, take this screw and that screw out. Then the thing just slides out. I didn't realize that these detach the foot down here. See, back up in there are two screws. There's one. That's a foot that keeps this from being pushed down. So I didn't take this out correctly. So a scratchy device of taking that capacitor out. Take these two screws out, and that allows the back of this unit to tip up just a little bit, pull it out. If not, the glass on the vacuum fluorescent display will hit this sharp edge and possibly destroy it. So, I'm always harping on replacing capacitors. Let's show you a striking example of the benefit of that. Here's the high voltage meter. You can see the bottom, not the ALC scale, but the one just above it. That's the plate voltage times 10. Before changing those capacitors, the needle went right there to about roughly 920. After replacing the capacitors, here's the unloaded high voltage, the KV. That capacitor, those two capacitors, where'd they go? These two old leaky electrolytics that were underrated on voltage. We can't put 500 working volt capacitors on a 1000 volt line. Two were in series. Can't do that. There was so much leakage in those capacitors, it was dropping the unloaded supply by 90 volts. Probably enough to cause internal heating. So, a few tricks here. The mechanical dial was off. There's a nut that's loosened to jog that dial. Pardon me. Then good luck retightening the nut. It might be better to snug the nut down and put a little bit of paint to lock that, but not difficult. The processor button was stuck. It wasn't clicking, and there was no microphone. The mic amp circuits were dead. The processor line biases on a transistor that pulls a mic amp, first mic amp transistor to ground. So I think that's why it had no talkie. So I had to take the front panel off. The front panel had been removed to replace some of these little light bulbs, and by loosening the bracket and repositioning these three switches, now the processor switch works. Would work if it's in sideband anyway. It's in tune now. There's a proc light. Processor light comes on with 9 volts. That 9 volts biases a switch on that grounds the emitter of the first mic amp. This radio has some rather complicated control and feedback systems. It is definitely not a radio for a beginner to work on. This is complicated. As you can see, the components are stuffed in there. The resistors are vertical, so really packed in there tightly. You can see this is a double-sided board. The brown boards here are single-sided. So several of these electrolytic capacitors had leads with solder pads both on bottom and top of the board. It makes them extra difficult to unsolder, and especially because the old solder is oxidized. So there's a specific process needed to not damage this board. And that is, identify the capacitor leads, paint them with flux, let it sit for 5 minutes for the flux to work. Use desoldering wick to remove the old solder. Tin on some new solder for the purpose of better heat transfer. That new solder should wick down in through the plated through hole. The pads on top and bottom of the board are connected by what are called a plated through hole, or PTH. The desoldering heat on the opposite side of the board has to reach through and down a component lead and to the other side of the board and melt all the solder in contact with the component lead. Or the component lead A won't come out, or B, it'll rip the pad off the top side of the board. So the process is to do that, remove the old solder, replace the old solder with new for better thermal conductivity. Do not try to heat both leads at once. I tried that years ago, it didn't work. It overheats the board. Needle point soldering iron tip. The purpose of the needle point is to reduce the heat transfer a bit. This is an oversized iron, but that fine point will allow contacting both the solder of the pad and putting heat right against the component lead, and the component lead has to be heated to couple heat up through that PTH and melt the solder on the top of the board. When that's done, you're heating one lead. Let's say we're heating the top lead on that capacitor. Heat that lead through and very gently bend that capacitor, and it'll pull that lead through the hole. Only part way. Stop, let that cool. Heat the other lead, bend it back the other way, and that will incrementally ratchet those leads out of the hole. Clean the board with isopropyl alcohol and Q-tips. Inspect for solder balls, remove any solder shorts. Because realize it's extremely bad to plant an electrolytic capacitor back down flush with that board and have a solder ball hiding underneath. Because it's probably going to be an intermittent, and it'll drive you crazy trying to find it. So as you can see right there in the center of the view, instead of against the board, that capacitor was laid on top of that IC. There's plenty of room overhead. This capacitor back here is elevated above the board about 3/8 of an inch. And that allows clearance to get a soldering iron and solder under the capacitor to solder the top side pad to the component lead. Now back in here, these capacitors back in this corner are a nightmare to get out because there's almost no clearance. And they're spaced above the board a 1/2 inch. So plenty of room for inspection. Solder the new capacitor in, clean board with flux, magnifying glass, inspect the board for solder shorts, and measure continuity through a manometer from the trace on the bottom of the board up through the PTH to the top side and to the next component it goes to guarantee if there's a circuit. If there isn't, if the pad on top of the board is torn away or doesn't solder, then you'll need to add a jumper under the board to bypass the plated through hole. So, control circuits. The final amplifier tubes have a complicated grid bias control circuit. They also have a step, 3 steps in the screen voltage, one for the tune function, one to limit current in CW, and then the highest for sideband. Because there's no such thing as key down in sideband. Key down doesn't send anything out on sideband. Key down is full dissipation on CW. And tune is limited, they say, for presetting the plate and load, which is useless. Because there were well-known ways to do that before this radio came along. The purpose for this tune appears to me to be for setting up, loading an amplifier, because it's producing about 40 watts on tune, and that's about grounded grid amplifier drive level. So I think the manual's incorrect. Here, let's get back up in the band. Okay, there's a complicated grid bias control for the final tubes. It's a minus 107 or 115 volt source. It's moderated by a low voltage plus source through a couple transistors. Strangely enough, there's a control input to the final grid bias from this switching power supply here, and a minus 6 volt source that goes to a switching transistor in the final grid bias circuit. And apparently, if there's a malfunction here, that's intended to shut down the finals. That might keep it from going off frequency and transmitting off frequency. There's also a grid bias control for the driver tube that is on, I think it's on the AF board underneath. So if you're looking for problems with biasing on these tubes, you'll probably find it in some goofy control circuit back under here. The microphone circuits go to here. First step in troubleshooting, no microphone drive is to put a scope or something on the mic gain pot underneath, because that's in line. The mic gain pot is before the balance mixer. So there's divide and conquer for the for no mic or no modulation. And for alignment, we can't just turn it on and start dilling those transformers down there. The instructions say the antenna port has to be terminated in 50 ohms. That's because even in receive, the receive and transmit circuits connected together there impose a load on receive through the final grids and out through the plate and out to the output matching network into the antenna jack. So aligning the receive requires a 50 ohm load on the antenna jack, whether the transmitter is on or not. And for adjusting receive, turn off the screen grid switch on the back panel, just for safety. Now these brown boards, be extremely careful unplugging those white connectors. It would be a real good idea to set the radio in a place that's maybe 100 degrees Fahrenheit, let it warm up for a few hours, soften that connector. Low temperature hairdryer, held maybe a foot away, warm them up, they'll come apart more easily. Don't pull on the wires, they're a real pig to resolder if you pull a wire out. But changing capacitors, pretty much the same process. When I'm done with that, if I change these, I'll put a black dot on top. There's some red inspection marks there, those are factory. So I use black and cover it up, saying that I've installed and tested that capacitor. Testing means check the capacitance value first. These capacitors up here are not the ordinary plus 80 minus 20. These are plus or minus 10%. They got to be close. So for these, especially check and verify the values. They're 10 microfarad, at least 35 volt. So you can probably hear the fan running in the background. That's taken off the 14 volt source. I think that's what's called in the manual. That's going to be replaced by this 15 volt 2 amp switching supply, which is going to be put right in here because it'll just fit. Yes, that's at the edge of the chassis, but the cabinet is beyond that, so that'll just fit in there. And pick up 110 AC from the heater switch as a trigger, and or route the 12 volt through the heater switch for an off on. But we want that heater switch function, but that can go inside here and supply nice, clean, steady, regulated 12 point something. Actually, they call for 13.5 on the filaments. There's a drop-in resistor in the final circuit. So that is a big improvement, and that takes 60 cycle off the tube. So there's no 60 hertz hum on transmit. The VFO assembly comes out by taking out 1, 2, 3, 4 screws. Pull it straight out. There are 2 of the little bulbs You see the dials lighted. There's one here and one there. Pull them out of their plastic socket, but pulled out very carefully and with the bottom cover off, because there's a connector on the back of this unit. I think it's a 5 position. It has to be unplugged. But other than that, this unit just pulls straight out. So that's necessary to take that out to get to these switches here and neaten up some of the wiring. Make sure there's no wiring pinch between the top of this and the bottom of the chassis that's protecting this board from underneath. There's only like that much clearance between the two, so not very much clearance. I don't usually do it, but have on this radio. I'm doing a board at a time. Made the power supply modifications, tested it, found the mic didn't work. Since the switching supply up here is critical, if those capacitors break down, it may destroy the transformer, so I redid that board first, put it back in, verified that it works. And it works. So then I did the front panel to find the stuck processor switch, and I'm going to test that and see if it does modulation. Then I'll depower it and start recapping these various boards, but testing them one at a time. It's probably better to do it that way, because if we do like I've done in the past and completely recap the whole unit at once, that's way too many chances to make a mistake and then trying to guess which board it's on. So, not a beginner's radio. If you're a beginner, don't touch this one. It'll bite you. So, and exposed 1 kV high voltage underneath. Careful. So that's pretty much it for the 530S.